Hello, everyone. I'm Professor John Nguyen, and welcome to Chemistry. This is part of Chapter 6, the acids and bases. And in today's discussions, I would like to show you more practice exercises focusing on calculating hydronium ion H plus, which is the same as H3O plus. Calculating OH minus, which is hydroxide ion concentrations, and pH calculations. All right, let's get into it. Okay, so here I have example. When we are given the molarity of hydrochloric acid solutions, HCl is hydrochloric acid, like in this case 0.00100 molarity of HCl, we can calculate H plus and OH minus concentrations. And after you have H plus concentrations, molarity, you can calculate pH. All right. Notice that the H plus multiplied by OH minus equal to 1 times 10 to the minus 14. That is a fixed numbers. That's called kW. Okay, so if you know the concentration of one H plus or OH minus, you put that in a denominator and you will get the other concentrations. Okay, in this case, we know H plus, which is the same as HCl because there's one hydrogens. Okay. Okay, so H plus is the same as the molarity of HCl. Now OH minus, all we have to do is take 1 times 10 to the minus 14 divided by H plus, which is 0.00100. Put that in a calculator, you will get 1 times 10 to the minus 11. If you have it set with scientific notations, if you have a TI calculator, TI 30 series, you can use these functions. You can also use anti-log or EE, okay? Remember that. And here's the hint for you to enter the number into your calculator. All right, so we got both H plus and OH minus. Now, if you take the minus log of that, later we're going to do some calculation for pH, okay? Minus log of H plus, you will get pH. Okay, in this situation, we have 0.0020 m sodium hydroxide. Now, because sodium hydroxide has one OH, the OH molarity or concentration equal to the molarity of sodium hydroxide, okay? And that's 0.0020. Now, to find the other one, which is the H plus, all you have to do is just take 1 times 10 to the minus 14 divided by 0.00220, and that should give you 5 times 10 to the minus 12 molarity. Okay, what this means is in a calculator, if you just hit the negative, the subtract sign, that's not negative. The negative sign is either in parentheses or plus slash minus or positive slash negative. What I mean here is it's different from the subtract sign. Okay. All right. Now here again, we got 0.050 molarity of HCl. Therefore, H plus is exactly the same, 0.05. and you take 1 times 10 to the minus 14 divided by 0.05, that should give you 2 times 10 to the minus 13 molarity. That's OH minus. So every time basically between H plus and OH minus, if we know one, we can figure out the other. Okay, and the 1 10 to the minus 14 always on the top, the numerators. All right. Okay, let's check out more calculations. Now we got 0.0050 molarity of sodium hydroxide. This time we calculate H plus, OH minus, and pH. And then we'll be able to tell if it's basic or acidic or neutral. Okay, OH minus is the same as given molarity of sodium hydroxide, because that's in there. Okay, 0.0050. H plus, take 10 to the minus 14 divided by that, 0.0050. You got 2 times 10 to the minus 12. Please let the calculator do the work for us. Okay. After you get the H plus, you take minus log of that, which is minus log of 2 times 10 to the minus 12. If you do it correctly, it will come out 11.7. Some calculator you do have to put in parentheses. Okay. Here's the hint how to put in the calculator. Okay. You should get 11.7. And don't worry about units for pH. It has no unit. Okay, now we got 0.0045 molarity HCl. HCl has hydrogen, as I highlighted here, underscore here, and that's exactly what hydrogen plus is, 0.0045. And then, if you have the hydrogen plus, you don't need OH minus to calculate pH, because pH is minus log of H plus. We already have it, 0.0045. That gives us 2.3, okay? Uh, if we follow significant figures rule, we should write 2.35, okay? All right. More H plus, OH minus, and pH calculations. 0.0100 m HCl, okay, that means we got H plus. It's the same as HCl. Okay, H plus represent acid. That's why. 0.01. Take 10 to the minus 14 divided by 0.01. We got 1 times 10 to the minus 12 m. And this is how you put in your calculator. And that's your OH minus concentrations. All right. Now, this one is interesting. We got 2 hydroxide. So to figure out hydroxide, we need to multiply it by 2. Okay. So it's not 0.00100, it's times 2, so that gives us 0.002. If we take 1 10 to the minus 14 divided by that, we got H plus. And of course, take the minus log of that, 5 times 10 to the minus 12, that will give you pH. Okay? All right. Here's more pH calculations. Now, calculate pH of 0.0010 m HCl solutions. Okay? HCl solution is the same as H plus. So, H plus is 0.0010. Take the minus log of 0.0010. That will give us 3. pH equal to 3. If pH is 3, that's less than 7. It is acidic. All right? The solution is acidic. Now, how about 0.005 molarity HCl, and that's the same as H plus. Take the minus log of 0.005, that gives us 2.3. Okay, that's also acidic because it's less than 7. Now, how about 0.0020? That's H plus again. All right, once we got an H plus, we just take a minus log of that, 0.002, and that will give us 2.7. All right, and here's the hint how to put in your calculator. TI 30 series. Okay, a couple more um, calculations. pH, 0.00100 molarity HCl. Again, take the minus log. We got 3. Okay, I think we've seen that before. 0.02 MHCl solution. Again, H plus is the same. Take the minus log. We got 1.7. 0.005. Okay, we got 2.3. And again, pH has no units. All right. So by now, we should be able to calculate everything from H plus to OH minus and pH. And remember, if pH come out to be less than 7, like this, 3, 1.7, or 2.3, those pH that's less than 7 tells us the solution is acidic. Remember, less than 7, acidic. Right at 7, we're talking about pH, neutral. Greater than 7, like 7.4, that's basic. All right. I hope you'll be able to calculate pH now. Okay. Thank you guys for watching and see you soon in the next video. Thank you again.